Okay, good morning. So today what we're going to do is we're going to correct the homework and then we're not going to move forward just yet. I want you to practice with more difficult examples. So if you struggled with this homework, take your time going through the solutions. If you're still struggling at the end of that, rather than moving on to the more difficult questions, I want you to try these ones again. You watch the video, try them on your own without the video, and see how you're getting on there. So this is a difficult topic and we'll take our time going through it with lots of practice. So the key to maths, especially with new ways of solving things, is to practice it over and over again. Now, let's look. So you had page 440 in book 1, questions 1 to 8. And the first question asked us to solve this set of equations. I'm going to label them equation 1, x plus y equals 5, and equation 2, x minus y is equal to 1. Now these are set up so that I can already cancel y because the y's have the same number in front of them and opposite sign. So I don't need to do any manipulating. I can just cancel y straight away by adding these equations together. At higher level, it will hardly ever come up in a nice straightforward way like this. You'll almost always have to do something. So then I'm adding them together and my new equation is going to be x plus x, 2x, the y's cancel, equal to 5 plus 1, 6. And then I divide across, so that's my new equation. I divide across by 2, so this gives me x equal to 3. So there's one of my answers. And then I substitute that back into the first equation. So instead of x plus y equal to 5, I will have 3 plus y is equal to 5. We do letters left, numbers right, and when I change sides, I change signs, so y is equal to 2. And there, that's it, that's my answer. I don't need to do anything else. We'll move right on to question 2 then. So question 2, the two equations were x plus y equals 14 and x minus y is equal to 2. And again, I can cancel y straight away with this one. I don't need to do any manipulation. So x plus x gives me 2x and y take y, they cancel each other out. 14 plus 2 is 16. So I'm adding the like terms together. They're stacked on top of each other so that they all line up. And then this is my new equation, which I solve by dividing both sides by 2. So x is 16 divided by 2 is 8. X is 8. And then I sub x back into, the first one is the easiest. So x plus, I apologize, 8 plus y is equal to 14. So y is equal to 14 minus 8. Moving sides, y is equal to 6. And those are my answers for the two values. Okay, question 3 is also set up nicely for us so that we can cancel y straight away. So question 3, my first equation is 2x minus y is equal to 7. My second equation is 3x plus y is equal to 13. So again, y is going to cancel y, but I don't need to do anything to it. 2x plus 3x is 5x, minus y plus y, they cancel each other out. It doesn't matter if the minus is in the first one or the second one, they just need to be opposite. 7 plus 13 is 20, and then I solve my new equation. I can divide across by 5. So you divide across by the number in front of the variable. So x is equal to 20 divided by 5 is 4. I sub that back in. 2x minus y is equal to 7. So 2 by 4 minus y is equal to 7. 8 minus y is equal to 7, which means minus y is equal to 7 minus 8. Minus y is equal to minus 1. And so what I'm actually doing here is dividing across by a minus 1 by the coefficient, but we can just call it changing the signs. So you can change signs so long as you do it to both sides of the equation. So we're back at this again. We must do whatever we do, we must do it to both sides. Both sides of the equation. And y is equal to 1 was the answer for my second variable. Now for question 4, it's going to get a little bit more complicated. I'm going to have to do some manipulation. So question 4, part 1, we had x plus 3y equals 10 and x plus y is equal to 6. So the first thing I have to do with this is I have to decide which letter am I going to cancel. And it looks to me like it would be much easier to cancel x because they already have the same coefficient. So I'll make the decision that I'm going to cancel x. And the way I'm going to do that is I'm going to change the sign of the second equation, because then I'll have x here and a minus x here. I'll cancel x and I'll do it by equation 1, no change. So no change to equation 1, and I have x plus 3y equals 10. So I just write it down, and I'm going to put a minus on equation 2. So that means I have to put a minus on the x, I have to put a minus on the y, and I have to put a minus on the 6 over there. Now I can add my equations together, and x will cancel. X take x is 0. 3y take y is 2y. 10 take 6 is 4. That's my new equation. I divide across by 2 to get y is equal to 2. And then I can substitute back into, it doesn't matter if I sub back into 1 or 2. In this case, this one looks a little bit easier. So instead of x plus y equal to 6, I will have x plus 2 is equal to 6, and x is equal to 6 minus 2. So x is equal to 4. Now you've probably noticed when you were doing your homework there was a V next to some of them. We were asked to verify. I haven't done that yet. I'm going to come back to that at the end and do them all in one go. Now let's look at question 5. So question 5, my first equation was 3x plus y equals 11. And my second equation was 5x plus y equals 15. So to me it looks like the easiest one to cancel would be the y, because I don't have to multiply by any number, I just have to change the signs. So I'm going to cancel y, and I'll do it by equation 1, no change. So I just write down 3x plus y equals 11, and I'm going to do a minus on my equation 2, which gives me, this becomes negative, minus 5x minus y equals minus 15. And then when I add those together, 3 take 5 is minus 2, the y's cancel, 11 take 15, sorry, there's an x there, 11 take 15 is minus 4. I can solve this by dividing by the coefficient. Remember, the coefficient includes the sign. So x is minus 4 divided by minus 2. A minus divided by a minus is a plus, plus 2. So x is equal to 2. And then we sub back into whichever one of these we feel like. So instead of 3x plus y equals 11, I will have 3 by 2 plus y is equal to 11, which means 6 plus y is equal to 11. Y is equal to 11 takes 6. You don't have to write down all these steps, but because it's still pretty new, I'm writing them all down for you to see. So y is equal to 5. And there are my two answers, nice and clear for the teacher who's correcting it, please. And finally, question 6. So for question 6, we had x minus 4y equals 19, and x minus 7y equals 31. That's equation 1, and that's equation 2. Now in this case, x is easier to cancel, and again I want to change the signs, so I'm going to write down what I'm doing to help me not make a mistake. I'm going to cancel x, and I will do it by no change to equation 1. So I just write it down. X minus 4y equals 19. And I'm going to subtract equation 2. So I change the sign of x, minus x. I change the sign of y, plus 7y. So when you minus something, a minus a plus gives you minus, a minus gives you plus. Equals, and I must put a minus sign there. The biggest mistake that people make with simultaneous equations is they forget to do the thing on the other side of the equals. And now let's put those together. X take x is 0, so they cancel. Minus 4 plus 7. If you're not good at adding these backwards, use the calculator to help you. And it's a plus 3. So 3y is equal to 19 take 31. I could do it in my head, but minus 12. Minus 12. So be careful with your signs there. We have opposite signs. We're going to get a negative answer. I'm going to divide by the coefficient of y. I'm going to divide by 3, and y is a minus 12 divided by a plus 3. It's a negative answer. It's minus 4. Then I sub back into, it doesn't matter which one, so x minus 4y is equal to 19. X minus 4 by minus 4 is equal to 19. X plus 16 is equal to 19. So x is equal to 19, take 16, and x is equal to 3. So those are the answers for my two variables. Now, let's do the verifying. I didn't do this in our notes the last day, so if you didn't do it for homework, that's perfectly fine. Verify. When you're asked to verify simultaneous equations, you sub back in the x and y values, and you must do it into both equations. Sometimes when you've made a mistake, it will work out for one of the equations and not the other. So we were asked to verify question 2, and for question 2 we got x equals 8 and y equals 6. X equals 8 and y equals 6, and our equations were x plus y equals 14, so let's verify that one first. Is 8 plus 6 equal to 14? It is. 14 equal to 14. So I verified the first one, but I'm not done until I verify the second one, which was that x minus y is equal to 2. So is 8 minus 6 equal to 2? Will it? Sorry. 8 minus 6 equal to 2? It is, yes. 2 is equal to 2. So once we verified both of them, we're happy that it's verified. We were also asked to verify question 4. So for question 4, we got, just double check, x equals 4 and y equals 2. X equals 4 and y equals 2. And the two equations, first one was that x plus 3y should be equal to 10. X plus 3y equal to 10. So is 4 plus 3 times 2 equal to 10? It is. That's 4 plus 6. So the first equation is correct. It's verified. Check my second one. Is x plus y equal to 6? It's pretty obvious there, I think. 4 plus 2 is indeed equal to 6. So I verified it. And finally, we were asked to verify question 6. So for question 6, we got that x was equal to 3 and y was equal to a negative 4. And for equation 1, we had x minus 4y equal to 19. So is 3 minus 4 by minus 4 equal to 19. Well, that's 3 plus 16. And yes, that's correct. So equation 1 is verified. Equation 2 is x minus 7y equal to 31. Is 3 minus 7 times minus 4 equal to 31? Well, that's 3 plus 28 equal to 31, and it is. 31 is equal to 31. So we've verified it. So that's how we verify. You can be occasionally asked to do that, and it does take a little bit of time. The important thing here is that you must do both equations or you won't get full marks. Okay, so I'm going to put up a little bit more practice from book 2 with these, and then tomorrow we're going to go back to coordinate geometry, and I'm going to show you how these link into coordinate geometry and why we learned them. Okay, thank you.